Hey kids, are you there? Can you see me? Okay, good. Well, today we're going to talk to you a bit about eyes, about human eyes, about compound eyes. It's the way insects see, and it's really neat because we see things crystal clear, one at a time, a great image. But insects, they see out of a compound eye, and they see a ton of them everywhere. So the way insects see, it's just like looking out of a kaleidoscope. It changes. Insects also see ultraviolet light. The way that when insects are looking for nectar, they see the ultraviolet colors and it brings them to it, and that's how they get food. Now you're going to hear a bit from my friends Britta, Ian, and Jed, and they're going to explain to you in a little bit more detail about the insect's eye.
Hi guys, Britta here. I'm going to talk to you a little bit about the human eye. So, we let light into our eyes through our pupils and our iris. So our pupils constrict when it's really bright, so we let in less light, and they get bigger. And the pupil is the black part of your eye. Also, we're able to see images, and they come into our eye, and then they flip upside down, kind of like I am right now. Then they go to our brain and are flipped right side up again. They transfer to your brain through cranial nerves, and we have 3 of them that connect to our eyes. So that's pretty cool, huh? Now that we know a little bit more about how our eyes work, let's go to Ian and Jed in the lab to learn about the insect's eyes and how they work.
The insect eye is a solid eye that is bumpy in appearance, which offers much more protection than our human eyes do. They're made up of over 40,000 subunits called ommatidia. One interesting fact about the insect eye is that they respond better to moving objects than stationary ones.
Well, welcome kids. Today we're going to talk about how the compound eye, which is found on insects, collects light and transmits to the brain, which is amazing. So, what we're going to do is take this complex model, don't worry, it'll get simpler as we go through it, and we're going to show you how it works. So, we will start with light, and light is taken in by the insect compound eye, which we have talked about earlier, and then the compound eye we will then break up into the different parts, which are called ommatidia. Each compound eye consists of hundreds and even thousands sometimes of ommatidia. These specific ommatidia units are then broken up into lens, which serves to focus the light that is focused into the ommatidia, and then is covered by a cornea, which serves as a protective mechanism, and then the light is channeled by the ommatidia using the lens into the rhabdom. The rhabdom is a very important part of the ommatidium because it contains the photoreceptors. Now, why are photoreceptors important? Well, guess what? It's because photoreceptors help us to differentiate the brightness and color that is received from all the light that comes into the ommatidium. Can you believe it? This is amazing. So, once we get the photoreceptor that collects the light and breaks it up into brightness and color, we can then transfer that into the optical nerve. The optical nerve then leads into the brain, which interprets the signals perceived by the ommatidium by the light from the compound eye into the images that are perceived by the insect brain. Now, what types of images are collected by the insect eye? Well, there's 2 particular types of images. One is called apposition images. These particular types of images are formed by individual ommatidium images collected and put together by the brain into a large image. Now, this is much better for contrast, but happens to sacrifice a little bit on the brightness of the image. So, how can an insect that perhaps survives in a nocturnal environment continue to go on and see things? Well, we're going to move on to superposition images. Superposition images are formed as a result of multiple fields collected by multiple ommatidium and put together. This increases the brightness and, unfortunately, sacrifices a little bit on the contrast. Gotta give and take in life. Alright, so, now that we've talked about that, there is one more important part we need to talk about. Each ommatidia is separated on the compound eye by particular pigments. These pigments are used in the regulating and transmittance of light through the ommatidia. That is also important with the apposition images and superposition images, because for an insect that perhaps needs to survive at 2 different times a day, it can transfer pigments in between its compound ommatidia and be able to see. Isn't it amazing?